in a class of 25 students, 14 like pizza, 16 like iced coffee, 1 student likes neither, and 6 students like both. 1 student is selected randomly from the class. What is the probability that the student likes pizza and B likes pizza given that they like iced coffee? So this is kind of the first gentle introduction into conditional probability, as in probability A of A happening given B's already happened. In our case, the probability they liked pizza given that you know that they like iced coffee. So if we start with A, actually it's as simple as it gets. So for A, so I'm going to say, I'm not going to write it down, but basically I'm going to say let event P be the event student likes pizza. Let event I be the event student likes iced coffee. So I'm looking for probability of P. So P, the probability of the student liking pizza. We randomly select them. When I say randomly select, it means that all 25 of these students have an equal chance of being selected. So equals, now it's just a simple theoretical probability formula. It's the number of favourable outcomes, e.g. the number of outcomes that involve the student liking pizza, well 14 like pizza, over the total number of possible outcomes. I can select any one of 25 students. So this is 14 over 25, which doesn't simplify. So for part B, I think I'm going to draw a Venn diagram to start. So we do have an intersection because we know there's 6 like both. So we do need to make sure our circles intersect. We do need a universe because we do have that 1 student who doesn't like pizza or iced coffee. And then if we have a P for pizza and an I for iced coffee, we can start to fill things in. So you start in the middle. I would always start in the middle with our 6 that like both. So 6 students like both. Then we work out how many like pizza? 14. So this number plus 6 must be 14. So 8 plus 6 is 14. For iced coffee was 16 like iced coffee. So this plus this must be 16. And 6 plus 10 is 16. And then we've just got our 1 student who likes neither, so outside the universe. Useful check. Seeing as we're told that there's 25 students in the class, you're never going to be told both of these pieces of information in practice, but seeing as we have it, might as well use it. 8 plus 6 is 14, plus 10, 24, plus 1, 25, so that's a good sign. So using the Venn diagram, probability, they like pizza given they like iced coffee. So this is different from just saying the probability they like pizza. Because if you know they like iced coffee, then well, you know they've come from here. So wherever you selected randomly, well, you know it was one of these 16 because they like iced coffee. So these 8 people don't like iced coffee, and neither does that 1 person. So you know the total number of possible outcomes is 16. And the number of favourable outcomes, so out of these 16, how many actually like pizza? Well, that's 6. 6 over 16, and you could simplify that to 3 over 8. Right, now using a formula, you will have to use this in some questions. In this one, we've just shown we don't have to use it. But this is a good one to remember. It's not quite in the formula sheet, not in this form anyway. So basically, probability of A happening given that B has already happened equals the probability of both, so A and B, over the probability of the given one, whichever is given. So probability of event A happening given that B has happened is the probability of both over the probability of the given one. So in our case, the probability of them liking pizza given that you know they like iced coffee equals probability of both, so that would be pizza and iced coffee, over the probability of the given one, as in iced coffee, P iced coffee. So that would be, well, probability of them liking pizza and iced coffee is 6 over 25. So it's 6 over 25 over, well, the probability of them liking iced coffee is 16 over 25. So what we need to do then, it will be 6 over 25 divided by 16 over 25. And you know that to divide by a fraction, you times by its reciprocal. So that would be 6 over 25 times by 25 over 16, which would still give you 6 over 16, 3 over 8. So we will be using this formula a lot more. But remember, the probability of A happening, given that B has already happened, is the probability of both over the probability of the given one.